A systematic review is often dead before the first piece of data is even collected. When thousands of primary studies are fed into a meta-analysis, the synthesis yields clinical value if that chaos is forced into a rigid methodological structure. The most common point of failure is conceptual incoherence. Researchers frequently misspecify the initial scope, defining a question that either cannot be answered by the existing literature or fails to reflect how an intervention actually interacts with its context. To avoid conducting an empty review, one that yields 0 eligible trials, authors have to engage directly with clinical stakeholders up front. You must define the exact dilemma decision-makers are facing before writing the protocol. Every proposed research question has to pass through a validation filter known as the FINER framework. It starts with asking if the review is feasible and interesting. Feasible means the breadth of the question won't return unmanageable volumes of data, or conversely, hit a dead end of 0 studies. Interesting ensures the author team has the sustained commitment required for a rigorous, multi-year synthesis. The question must also be novel, ethical, and relevant. A review that duplicates existing literature or ignores current health technology assessment guidelines is just research waste. Bypassing this initial validation guarantees a garbage-in, garbage-out scenario. An unvalidated question circumvents clinical utility, rendering the downstream meta-analysis mathematically flawless but practically useless. Systematic reviews of interventions specifically support clinical practice and policy. They assess the balance of benefits and harms to provide a direct evidentiary foundation for healthcare decision-making. This policy application relies on the PICO framework, which operates as a 3-tiered structural hierarchy: population, intervention, comparator, and outcome. At the top is the review PICO. This is the broad, protocol-level boundary that dictates your overarching eligibility criteria, what gets into the review and what gets excluded. Below that is the synthesis PICO. This dictates the exact mathematical framework of your meta-analysis, defining which specific intervention groups will be explicitly compared against each other in the actual data crunching. Finally, at the base, you have the included study PICO. This is the ground-level reality of what the primary investigators actually investigated in their distinct trials. Look at diabetes management. Your review PICO might look broadly at any anti-diabetic drug for adults. Your synthesis PICO narrows that to a strict comparison of SGLT2 inhibitors versus metformin. Your included study PICO is the specific 10 milligram dosage that was isolated in a single, perfectly controlled randomized trial. Failing to mathematically separate these 3 levels leads to conceptual flaws. You end up attempting to synthesize disparate clinical data that were never meant to be aggregated. Setting the breadth of a protocol involves a strict trade-off. A broad scope increases the generalizability of your findings, but risks overwhelming the analytical model. A narrow scope is easier to manage, but the resulting evidence is often too sparse for definitive policy decisions. There is a common professional critique that broad meta-analyses improperly mix apples and oranges. Statistician Jean Glass addressed this directly. Comparing identicals is scientifically trivial. Synthesizing variance is how we understand underlying mechanisms. Managing this variance across trials exists on a methodological continuum known as lumping versus splitting. Lumping aggregates diverse populations or varied formulations into a single analysis. The goal here is to explore specific reasons for differential effects, probing how an intervention's efficacy changes across different contexts. Splitting separates those comparisons down into their smallest homogeneous components. This isolates the data to calculate highly precise, albeit very narrow, average effect estimates. If you are evaluating newer generation antidepressants, lumping allows you to analyze the entire class of drugs to prove general efficacy. Splitting restricts the analysis to isolating specific molecules, like fluoxetine or paroxetine, to inform strict formulary decisions. Each approach carries a distinct risk. Aggressive lumping threatens the entire review with severe, unexplained heterogeneity, a statistical blur. Aggressive splitting shrinks the sample size until the evidence becomes too sparse to be usable. Scoping breadth dictates what data you collect. Analytical lumping dictates how you combine it. Both are deliberate mathematical choices that directly determine if a review will survive a rigorous health technology assessment. An optimal protocol relies on established priority-setting exercises. Aligning the review's exact question with the stated needs of decision-makers prevents the massive waste of resources on clinically irrelevant endpoints. When scoping decisions map directly to global institutional priorities, the systematic review anchors itself to international health policy, ensuring the findings address existing gaps in population care. A core component of this is health equity, the absence of avoidable and unfair differences in health. Methodologists use the Progress Plus framework to systematically categorize vulnerable populations by variables like residence, race, and occupation, and socioeconomic status. This is critical because well-intended policies can actively widen health inequalities. If a systematic review ignores socioeconomic access barriers during the scoping phase, the resulting guidelines will heavily favor populations that already have systemic advantages. Even with rigorous upfront planning, protocols require fluidity. As new evidence emerges during the review, the initial question may need adaptation. The strict rule here is that any post hoc modification must be rigorously documented to guard against outcome reporting bias. You also have to build contingencies for sparse data. If a specific PICO element returns too few trials, the protocol should pre-specify how to broaden the categories, shifting, for example, from vitamin C to any antioxidant to salvage a statistically informative synthesis. Perfect methodological rigor means nothing if the systematic review operates in a vacuum, failing to account for real-world inequities and stakeholder realities. When analyzing complex interventions, researchers use logic models. These are visual blueprints that map an intervention's underlying theory of change, defining exactly how it is supposed to produce a clinical result. The pathway is sequential. It tracks the physical inputs and clinical activities, mapping how they generate immediate outputs, which trigger proximal outcomes and ultimately lead to distal, long-term health outcomes. The main causal pathway doesn't exist in a vacuum. The model explicitly maps how the external environment, the context, and the internal biological or behavioral responses, the mechanisms of action, modify the intervention's effects. In a health economic scenario, this model traces causality precisely. It tracks how a drug administration alters a biomarker, which theorizes a change in distal outcomes, like reduced hospitalizations, that drive long-term economic savings. By mapping these causal links, researchers can differentiate between two distinct failures. They can prove whether a null result was an implementation failure, where the clinic simply failed to deliver the drug as intended, or a theory failure, where the intervention's mechanisms did not lead to the theorized outcome. Because policy decisions are constrained by available resources, review authors often incorporate economic data, such as resource utilization and cost-effectiveness. This economic context is essential for assessing the applicability of the review to a specific health system. This causal architecture provides the bridge required to justify surrogate endpoints within economic models. Without a robust logic model, a review lacks the theoretical depth needed to inform the resource allocation decisions made by health ministries and insurers. We've traced the architectural journey of evidence synthesis, validating the question through the finer criteria, separating the PICO hierarchy into 3 layers, and constructing logic models to track complex causality. If you are interviewing for an HEOR position, explicitly point to logic models. Explain how you use them to establish the unbroken causal chain that defends the inclusion of surrogate endpoints in your cost-effectiveness analyses. If you are preparing for clinical research board exams, frame data variance exclusively through the lens of the lumping versus splitting continuum. Show that you understand heterogeneity is a strategic choice, not just a statistical accident. And always reiterate the strict methodological rule. Protocols can adapt to data, but any post hoc modification to a review question requires exhaustive documentation to eliminate the threat of outcome reporting bias. A meta-analysis is only as strong as its blueprint. The ultimate clinical authority of a systematic review relies entirely on the precise, deliberate, and rigorous design of its initial scoping protocol.